Number 7 says in the parallelogram ABCD, the coordinates A are 3, 7, and the coordinates of B are 6P, and the coordinates of D are 1P. And it says it is given that the gradient of AB is minus 2/3, and part A says find the value of P. So we're given point A and point P, and we're told that the gradient is minus 2/3, right? So for us to find the gradient D, it's P minus 7 over 6 minus 3, right? And we're told this is equal to minus 2/3. So you can also start with 7 minus P, but make sure that if you start with 7 minus P, you also say 3 minus 6, right? So now with this, we cross multiply. 3P minus 7 equal to minus 2. 6 minus 3, that's 3, right? So 3P minus 21 equals minus 6. And 3P equal to minus 6 plus 21. 3P equals to 15. Then dividing by 3 on both sides, we get P to be 5, right? P is 5. Then for 2 marks, it says find the coordinates of C. So I'm going to try and draw a sketch, right? So our shape is something like this, with A, B, C, and D, right? It doesn't have to be accurate, it's just a sketch. So A is 3, 7, 3, 7. B is 6P, and C we're going to find D is 1P, right? And we know that P is 5, so I might as well write 5 D. It's 5 and it's 5 here, right? So if this is 5 and this is 5, we can try and draw a more accurate diagram with the 5s on one side. So it will look something like this. So D and B should be on the same side. So let me try and say A, B, C, and D, something like this. That I say this is maybe 6, 5, and 1, 5. Or maybe if I put D here, makes more sense. So let me redraw this. If D is here, B is here, so A, like that. So now this is 1, 5, this is 6, 5. They have the same y coordinate, so it is a horizontal line, and our A is 3, 7. So to find C, we're going to say from A going to B, we can see that we move 3 units, 3 more units. Oops, my diagram is not accurate, but I want to try and show that we move 3 units in the x-axis to get to 6. It's like 6 minus 3. We move 3 units. Then to get to 5 from 7, it's 7 minus 5. So we get minus 2. So it's like a transformation. We move 3 units to the right. I know my diagram is not accurate. Then minus 2 units to get to minus 5. Like that. So we're going to try and apply the same here, right? So if on the x-axis we're moving 3 units, so it means on this one we're going to add, so it will be 1 plus 3, then we get 4. Then on the y-axis you're moving minus 2, so it will be 5 minus 2, then you get 3. So it means 4, 3 is the coordinate for C, right? Then part C says find the area of the triangle formed by the perpendicular bisector of AB, the x-axis and the y-axis. So first of all, for us to get the equation of the perpendicular bisector of AB, we need the gradient of AB and the midpoint of AB. And the midpoint of AB. So the gradient of AB, using point A and point B, you can say 7 minus 5, 7 minus 5, then 3 minus 6. So 7 minus 5 m and 3 minus 6. So this will give us 2 over minus 3. So it's minus 2/3. And we know that the gradient of a line multiplied by the gradient of its perpendicular bisector gives us minus 1, right? And that tells us that the gradient of the perpendicular bisector is, so m of perpendicular bisector will be 3 over 2. So that if we say 3 over 2 times minus 2 over 3, we get minus 1, right? So having this gradient, we're now left with the midpoint. So to get the midpoint of AB, we add the x coordinates and you divide by 2. So that's 6 plus 3 over 2. 6 plus 3 over 2 for the x. And for the y's is 7 plus 5 over 2, which is 12 over 2, which is 6. So this will be 9 over 2 and 6. So this is the point that you're going to be dealing with, and this is the gradient that we'll be dealing with. So to get the equation of the perpendicular bisector, y minus y1 equal to mx minus x1, right? So y minus 6 equal to m 3 over 2 x minus 9 over 2, right? So y equal to 3 over 2x minus 27 over 4 plus 6, right? So minus 27 over 4 minus 27 over 4 plus 6, that's minus 3/4. So y equals 3 over 2x minus 3/4, like this. And we're told that we need to find the area of the triangle formed by the perpendicular bisector of AB, the x-axis and the y-axis. So the y-axis is vertical, and the x-axis is like this, and this line is probably like this. So we're being asked to find this area, right? So we're going to need this point and this point. And for us to get this point, the y-intercept, we know on the y-axis x is 0. So if we put 0 here, we see y is equal to minus 3 over 4. So here it will be 0 minus 3 over 4, right? And for this point right here, on the x-axis, y is 0. So it's 0 equal to 3 over 2x minus 3/4. So 3 over 4 equal to 3 over 2x. So we just divide both sides by 3 over 2. So we get x equal to 3 over 4 divided by 3 over 2. X equal to half. So this is half, 0, like that, right? So we can see that this will be the origin, right? This will be our base. I'll just use a different color. this is our base and this is our height. So our base is half and our height, it will be 3/4. Diagram is not that accurate, should be 3/4. So saying from 0 to this point, what is the length? It's just 3/4. Can be negative. Then over 2, it's base times height over 2. So it will be half times 3/4 divided by 2. Then we get 3/16 square units is our area, right? And that's it for number 7.